Chapter 4, Section 1, Motion Instruction. Create a new task. Click Save, Save Task As. Give the task file a name. The common picking up task just needs the joint move instruction move J and the linear move instruction move L. The robot will move to each waypoint with the specified move type. For common picking up tasks, choose fixed position as waypoint type, then teach the target position. The simplest and most practical design is using Move J instructions to move the robot above the object, then using Move L instructions to move straight down to the pickup position. Control the configured tool I/O signal to grab the object. Wait for the object to be grabbed, then move straight up to pick up the object. Section 2, Loops. The program structure for object placing is the same as object picking up, except the gripper needs to be opened instead. This is the general program structure for an object transporting program. There are two ways to loop the task. The first way is changing the running mode to cycle. With an if instruction, the task can be more controllable, such as using an external signal to stop the loops. Or executing the pick and place motions only when a signal tells it to. The result will look like this. The second way is using single running mode, but the program needs to be repeated inside of a loop instruction. The loop instruction can be set to loop specified number of times or loop when a condition is met, so it's more controllable. Add an if instruction to control the pick and place motions. Save all changes. The running result will be the same. Section 3, Variables. A variable can be created for counting the number of task completions. Under the Configuration tab, go to Global Variables and create a new variable. The variable type will automatically be updated with the initial value. An integer is enough for a counter, so input 0 as the initial value. At the end of the task, set the variable to increment by 1. The value of variables can be monitored under the Monitor window or Run tab. The value of a global variable can be modified under the Global Variable window. Section 4, Thread and Switch. If users need a method that allows them to reset the counter at any time when the task is running, A thread instruction can be added to the task to accomplish this. The thread runs parallel with the main task. Put an if instruction under the thread to check the status of the counter reset input signal. If the signal is high, reset the counter variable. If the users want the task to handle the defective object with a different routine, a switch instruction can be used. The switch executes a different routine upon the signal status. Make the robot drop the defective object into a dumpster. And place the acceptable object to the specified position as normal. Save the changes. The result will look like this. Section 5. Payload change. The cubes used in the video were lightweight and had a negligible effect on the payload. However, in real applications, if the work pieces are more than 0.3 kilograms, then the payload needs to be changed accordingly when picking up and placing a workpiece. This is a set of sample parameters. The payload parameter usually can be calculated by some mechanical design software, such as SolidWorks. In the Configuration tab, add a payload setting for handling a workpiece. In the task, after the gripper grabs a workpiece, use the set payload instruction to change the payload to with workpiece. After the gripper lets go of a workpiece, change the payload to gripper only.